We got bogged down a little bit in all that cool algebra I was trying to show you. I got worked up in the algebra yesterday, that proof, and I was feeling pretty awesome as I was going through it. But I think it might have been a little too deep for some people, so I want to take that. Thank you. The thing is, I want to get a little bit more into the actual what we're actually doing here. Okay. As far as the definitions from yesterday, let's go through the definitions. You need to understand these for what we're going to do today. That's March 6, 2015. Okay, in general, this is dot product applications is our note today. I'm going to sort of intermix the homework take up with my lesson, if that's okay.
So we're skipping warm-up?
Yeah, just let me know warm today. We're going to mix these two things, okay? Dot product application. So what dot product does mix this first mix? We decided, if you weren't here yesterday, our test is going to be the Wednesday after the March break. That's what we decided on, right? So the Wednesday after the March break, that's what we picked, okay? So what the dot product is here, if this is U, right there, and this is V and that's theta, we're going to say that U dot V is magnitude U, magnitude V cos theta. So what that means is, it's the multiplication of like the x-coordinate of the U vector times the magnitude of the V vector multiplied together. Okay, that's what that's going to be. Okay. Can somebody tell me a fact about perpendicular vectors and why that's the case? What do you guys know about perpendicular vectors? Yes.
0
per clock. Very good. Cos of 90 is going to be 0. So if U dot V equals 0, therefore the vectors are perpendicular.
It's 0 vector.
We'll leave that for right now, okay? Because what we're going to say is, right, if you're doing two vectors that are perpendicular, if you think of like the shadow or the x-coordinate of this is going to be nothing, right? So 0 times this is going to be 0. The other fact that I wanted to do, and this is what we did in the big giant proof yesterday, I'm going to say if U is going to equal A and B, and V is equal to C and D, what is U dot V equal to? Amy, go ahead. Very good. You're just going to multiply the coordinates and add them together. Okay, that's what yesterday's lesson did. I took 75 minutes to go into proofs and all that sort of thing, but those are the three key things you need to know from yesterday's lesson. Are there any questions with those three things before I get into the homework? Because those are the three fundamental things we did yesterday. If you weren't here, just relax and we'll get you into it, okay? But for everyone else, those are the three fundamental things we did yesterday. Yes? For most people? Okay, good. Let's get into the homework take up now, because these are the three fundamental things we need. Cover some stuff. Before this,
Got mine already.
I stole yours already?
Yeah.
No, I didn't.
You did. I'm saying that.
Matt, good thing you keep me honest here. I would have taken my home with me, and I'd have it right there. Okay, 3 A or B or C. I picked. Doesn't really matter. C. Is that okay? Okay, so it says, use properties of the dot product to expand and simplify each of the following where K and L E are. So we're going to say U minus V. Oh, this one's easy. So U minus V dot U minus V. Dot U minus V. Okay, so what I did is I gave you a huge amount of vector stuff that we dealt with yesterday. We had a whole bunch of rules. What do you know about U minus V and U minus V? How are they related? They're both the same thing. So what's the angle between two vectors if they're both the same? 90 is incorrect. 0 is correct. Okay. So really this is like technically magnitude, I'm going to use the other thing, so magnitude U minus V. Magnitude U minus V cos 0. Because it would have to be the same vector. Can someone please think back to the unit circle days? What does cos of 0 equal? Thank you. One person in the class understands trig. This is going to be painful when you get to trig. I didn't mean to say it like that, okay, but okay. So this is equal to magnitude of U minus V. Magnitude of U minus V. What is the magnitude of U minus V times the magnitude of U minus V equal to? magnitude u minus v squared. Okay, which hopefully is what it said in the back of the book. We're hoping. Answer's right there. Is that what it really said? I'm saying that's a good answer for it. Okay. All right. Do you get the logic of what I did there, though? Right. I'm just sort of using u rules there. Now there is another rule that says a dot a is equal to magnitude a squared. Okay, that's basically what I use there. So if I show my work. Are most people okay with my algebra there? Yes? Okay, please be brave and ask questions. I apologize. I had a huge amount of material to get through yesterday, so I didn't really care if you understood or not. I just wanted to get through that. I hate to say it. Okay, but I had to ramble yesterday, okay? So I have more time, so if there's questions, please be brave and ask, okay, for things, okay? So I know the last 2 days I'm embarrassed. Nate said he didn't understand I and J, and he just didn't care. He just kept leaving on me going, okay? Jeff also asked me yesterday, he had some problems with dot product, okay? He just let me go and he just let me keep on rumbling through, okay? Today, please stop me. Sounds like I'm losing my voice. If something's not clear, please be brave and try to stop me. Okay, so I will not have a little bit of time in today's lesson for questions. You guys are so kind so far. Okay. Let's keep going here. We're up to 14a. Said. I'm going to put this right here so I don't take it home with me. Okay, I'm just going to drop it right here. 14a says prove each vector properties of each vector. So A says if A and B are non-zero, A dot B equals 0 if and only if A is perpendicular to B. So what we want to prove here is that A and B are not the zero vector. Prove that A dot B equals, yeah, but it says using Cartesian though, so prove this with Cartesian. So if and only if A and B are perpendicular. Okay, so let's start with the left-hand side. Okay, what if and only if means that it you're going to start by starting with it perpendicular and showing that it equals 0, and then also that if it gives you the equation to show that it's perpendicular. That's what if and only if. You guys started with if and only if before or not? Basically, it's like a double proof. That's what it is. Okay, so you have to prove that A dot B equals 0 shows that it's perpendicular. And then if it's perpendicular, it means it shows that A dot B equals 0. That's what if and only proof is here. So how are we going to do that then? Okay, so we're going to say so using Cartesian vectors, okay. This is going to be tricky with Cartesian, isn't it? So vector A equal AX, comma BY. Vector B equal to let's try this again here. AX, AY. Vector B is going to be BX and BY. Okay, so we want to dot them. If you do A dot B, what's A dot B equal to, please? So AX, BX, yeah, AX, BX, plus AY, BY. Okay, that's what those two equal. Okay, so it says this will only work. So it says we have to show that we have to make them perpendicular. Okay, so we did a little bit of an example with what number was this? You guys were helpful. What I was helping people with. Was it number 10? Right, number 10 was one like that. Okay, and the way I did it with algebra. Okay, like this. So what I'm saying is if this equals 0. What's the best way to do this? I'm trying to think of the best way to do this. Well, because if you do numbers, though, it's not the general case, though. Because well, because basically what I'm going to do is here, I'm going to make this equal 0, and then I'm going to isolate a variable. That's what I'm going to do, though, right? I think there's a better way to do this. I think what I might do is I'm going to leave this for right now, and I'm going to let Michael start off the lesson for me today, and I'm going to get a nice, beautiful solution for you that makes sense, okay? But this is the idea of what we're going to do for this, but the problem is showing that this is perpendicular. That's the thing, right? So getting, you know what I mean, them in terms of each other to show what they're perpendicular. This is easy to do using the other method, right? Because then you can just say, well, the only way it equals 0 is if the vectors equal 0. So doing it without Cartesian, the way you do it is I do magnitude A, magnitude B, cos theta equals 0. And if, then we're going to say, well, A can't, magnitude of A is not 0. Magnitude B is not 0. Thus, cos theta equals 0. So theta is 90 degrees. Right? That's the way to do it with the regular vectors. With Cartesian, it's a little bit trickier here. Okay, so I'm going to think about that for a minute here. Yeah, go ahead.
Okay, for the top part,
Yes.
like what you could do is I used using the coordinate I found the slope.
Yes.
So the slope was just
Oh.
y over x.
Okay,
So
yeah.
then the other one is just the negative x over y.
Oh, good.
So then you could change your ax to negative by.
Okay.
And then you have
okay.
the same thing, but they're opposite, and then
Okay.
they equal 0.
Okay. Oh, okay, yeah. Okay, sounds good. Okay, I'll write that up for me. Okay, that's good. I think that's the way you got to go along with that. That makes sense. So what we said there, for things to be perpendicular, right, they have to do the negative reciprocal, their slopes, right? So you pick the point then, right, from 0 to that. For the negative reciprocal then, again, right, the slope's going to start at 0, so it's going to be the opposite. I'll pick a nice solution, get it up on the board here afterwards, but that's the logic behind it there for that. Does everyone understand this one though before I continue? Because the bottom half, this is that's sort of the form without the Cartesian. Okay, right? So if AB cos theta equals 0, and we said at the top that A and B aren't 0, then obviously cos theta is going to be 0. Let's move on to 18A, then we'll keep going here. So it's going to say here, 18B, 18B. It says, I'm trying to prove U dot V plus W equals U dot V. Is this right one? V? Yes. Plus U dot W. Plus V U dot W. Okay, so this is, I think, going to be a left side, right side proof is the way this is going to go. So the way I'm going to set this up is I'm going to set U is equal to UX, UY. V is going to be Vx, Vy, and W is going to be Wx, Wy. Okay, are we okay with that before I continue? Okay, so if I want to do U dot V plus W, how am I going to start that on the left? Amy, go ahead. Yeah. So, yeah, good. Very good. So I'm going to write it in here first. So UX, UY dot bracket VX, VY plus WX, WY. Okay, so I just wrote that out. And then what Amy said was when you're adding Cartesian vectors, you just add the coordinates, right? So could somebody other than Amy tell me what the brackets are going to equal, please?
Ax plus wx.
Yeah.
Vy.
Right. So good? Okay, so other than the front row, sorry front row, you're kicking butt again today. It's bad news here, you're out. Can someone in the second or the third row show off their dot product skills, please? And do their dot product for that. No one's brave. Dot product, what dot product is? Thank you for asking. Dot product is all the stuff we did at the beginning. So this is all the dot product of these three things here. Okay. So U dot V is going to be the first one times the first one, plus the second one times the second one. With that hint, what is this going to be then? Nate, go.
Is it UX bracket VX plus WX and then plus UI bracket VY plus WY?
Very good. And I'm going to distribute call that UXVX plus UY, oops, plus UXWX plus UYVY plus UYWY. Okay, please be brave and ask if we are okay on what happened there. Okay, so what I did was I just broke everything into components and then I distributed it as I could. Okay, so when I did V plus W, again what I did was then I just added the components of them, got a new vector for it. Then when I did my dot product, I multiplied the x coordinates together and then I added them to the y coordinates. So far so good? I mean, this is sort of yes?
Mr. Sadler.
Yes.
So you're working with the left side?
Yeah, so this was the left-hand side, that's what it equals to. I'm going to do the same thing with the right-hand side now. Thanks for clarifying that, Michael. I'm going to do the same thing with the right hand, so I should probably write that somewhere. This is the left-hand side. I'm going to do the same thing with the right here, and hopefully get it to be the same.
Working with the right side, could you just do the UVs together and the UWs together? And since we know that a dot or something is that, then we can just go backwards?
Yeah, yes, that'll work. I'm gonna stick with this right now, but that'll work the same way, yes.
This might sound really, really stupid,
Nope.
but why don't you just FOIL the U into the V and W bracket?
Because it's dot. We don't know. We're trying to prove that actually works. So it says to use components. Like you can't just automatically say that's the case. That's what we're showing.
Then what is the dot? Like, what does it equal officially?
It equals the x coordinates multiplied by the x coordinates, and the y coordinates multiplied by the y coordinates. Okay.
I'm gonna write that in.
So you don't know necessarily that it can distribute like that. Okay. So let's do the same thing with the right hand side. So this is going to be ux. Where we are? Ux uy dot vx vy plus ux uy dot wx wy. Okay, can someone be brave and show off the dot product skills? So I front rows out, sorry, Amy. The second back. You want to try it? Go ahead. Good. Ux vx plus uy vy. Good. Great.
How do you know that's like the right answer to get down? Like, I got it down.
Well, the whole thing is it's all distributed out. Now we're just going to match up to make sure it matches here, right?
So you always have to do both sides.
Yes, for this one, okay. So what I'm going to do is I'm going to say now, this ux vx matches this one, so that's good. Uy vy, oh look at that, that matches up. Ux wx, look at that, that matches up. And uy wy, that matches up. Therefore, left side equals right side. Remember that. Oh, Michael's working up a solution, I love it. Okay. So you see what I just did there? I just worked out without each side, distributed it, and then it actually worked out in the end. Okay, questions and fears. This is tricky. This is a little bit theoretical, right? And this is what makes this difficult, because you can't put your hands on it. This is not data management. Okay, sorry, data management is a good course. I loved it in high school. Yes?
Where'd the dot go?
Which part?
How does the dot go?
Because I'm just saying this here. Because what the definition of dot is you're multiplying this times this, and you're adding it to this times this. That's the definition of dot was. So remember, like if I were to do like 2, 3, dot, 1, comma 4,
Okay.
that's the same as 2 times 1 plus 3 times 4, right? So what I did was I did this times this, which is ux vx, plus uy vy. Okay, and the same thing, ux wx plus uy wy. Right, so just, you know what I mean, like you're multiplying each set of components. This is tricky from last night because it's all variables, right? That's what makes it difficult, and components and stuff instead of dealing with numbers. Okay. Today we're doing applications, so it's all numbers. Yes, I love numbers. Looks like we get to graphing. Okay. All right, I'm gonna hit pause the video. I want to tell a joke about my great French class. Okay, I'm gonna hit pause on this and make sure life is good. We love good.